मेरे बच्चों, हम टॉपिकों की सीरीज में आगे बढ़ते हुए आज एक नए टॉपिक पे चर्चा करने वाले हैं। मैं संदीप सारण, फिजिक्स लेक्चरर, आपके इस ऑनलाइन एजुकेशन के प्लेटफॉर्म पे आप सबका हार्दिक अभिनंदन करता हूं। आप हमारे इस चैनल को सब्सक्राइब कीजिए, ज्यादा से ज्यादा बच्चों को शेयर कीजिए। और सबसे अच्छी बात यह है कि किसी भी टॉपिक के कंसेप्ट को समझने के लिए आपको वो टॉपिक पूरा देखना चाहिए। मैं आपसे यही रिक्वेस्ट करूंगा कि आप प्लीज वीडियो को पूरा देखें, जितने भी टॉपिक देखें उनको पूरा देखें। ये टॉपिकों की एक सीरीज है, एक टॉपिक के बाद दूसरा टॉपिक, दूसरे के बाद तीसरा टॉपिक है। तो लगातार आप टॉपिकों को देखते जाइए। तो मैं ये पूर्ण विश्वास के साथ कह सकता हूं, मेरा दृढ़ विश्वास है कि आपको फिजिक्स के इन चैप्टरों में और इन टॉपिकों से रिलेटेड कोई समस्या नहीं रहेगी। तो चलिए हम अपने एक नए टॉपिक के साथ आज फिर अपनी यात्रा की शुरुआत करते हैं। आज जो मैं टॉपिक चर्चा करने वाला हूं वो है कॉमन पोटेंशियल। और आप चाहे नीट का पेपर देखें, चाहे जेई का देखें या कोई भी कंपटीशन देखें, इस कंसेप्ट के ऊपर न्यूमेरिकल 100% मिलता है। मैं आपको न्यूमेरिकल भी बताऊंगा कैसे कैसे क्वेश्चन पूछते हैं, बोर्ड एग्जाम में क्वेश्चन की प्रकृति क्या हो सकती है। मैं हर पॉइंट पे बात करूंगा इस टॉपिक को लेके। आप बिल्कुल हमारे साथ जुड़े रहिए। आपका प्यार हमारे साथ ऐसे ही बना रहे, हमें मोटिवेशन मिलता है। आप ज्यादा से ज्यादा इस चैनल को सब्सक्राइब करें और ज्यादा से ज्यादा बच्चों को इसका लाभ मिले, इसलिए ज्यादा से ज्यादा शेयर करें। तो देखिए, कॉमन पोटेंशियल कंसेप्ट क्या, व्हाट डू यू मीन बाय कॉमन। पहले कॉमन वर्ड को समझ लीजिए। कॉमन मीन इट इज सेम बिटवीन द डिफरेंट थिंग्स। तो डिफरेंट डिफरेंट चीज है, उनके अंदर कॉमन हो, उसको हम एक कॉमन शब्द बोलते हैं, जो सेम हो। यहाँ क्या है, कॉमन पोटेंशियल। इसका मतलब है कि दो या दो से ज्यादा, टू और मोर कैपेसिटर हैविंग द कॉमन और सेम पोटेंशियल। हम क्या करते हैं कि जो कैपेसिटर ले लेते हैं, सपोज कर लीजिए ये हमने एक पहले कैपेसिटर ऐसा लिया, दिस इज द कैपेसिटर फर्स्ट एंड दिस इज कैपेसिटर सेकंड। both capacitor have their different capacitance. It has the capacitance C1 and it has the capacitance C2. And initially they are at different potential. This have potential V1 and this have potential V2. And charge on these capacitor also different. This have the charge Q1, we write as Q1, and this have the charge Q2. They are separated. They are not connected to one another. Individual existence of these capacitor also take place here. First capacitor having capacitance C1, this have capacitance C2, mean these are the storage power. Then they are at different potential. At any instant we consider V1 is greater than V2. At any instant, in these two, one have the high potential as compared to other potential. So we consider this capacitor have the large potential, then this, it does not mean that it has a negative potential, it has positive potential. It means that both have this slightly different potential. This is at high potential with respect to this. Now they are connected. This is the first situation first. Now these are connected by a conducting wire. Now this capacitor is this is this. It has capacitance C1, it is also capacitance C2. They are connected by the conducting wire. They are connected by the conducting wire. Then due to this conducting wire, and it is very important things here, this conducting wire do not have storage power. ये चार्ज को स्टोर नहीं करेगा, सिर्फ ट्रांसफर कराएगा। तो चार्ज का मोमेंट हाई पोटेंशियल से लो पोटेंशियल होगा। Charge transfer from low potential to high potential up to or till both have at same level of potential. जब यहां से चार्ज का मोमेंट होने लगेगा, और चार्ज का मोमेंट कैसे होता है, हाई पोटेंशियल से लो। एक पोटेंशियल यहाँ है, एक पोटेंशियल यहाँ है, इससे चार्ज फ्लो होगा इस लो पोटेंशियल की तरफ। ये इसका लेवल गिरेगा और इसका लेवल अप होगा, और दोनों के दोनों एक स्टेज पे आ जाएंगे, इक्वल पोटेंशियल। जब जैसे ही इनकी पोटेंशियल इक्वल हो जाएगी, उस समय there is no moment in between charge. Mean this have the large potential and this have the low potential. As they are connected by wire, and this wire have no capacity to store charge, only to transfer or moment the charge from high potential to this potential level decreases and this potential level increases as they reach at the equal stage. And at this situation, its potential is V, its potential is V. Both have the same potential, but charge is different. This have the charge Q1 dash, this have the charge Q2 dash. Potential are equal now, and this potential is known as the common potential because it is same for both. Here we write that let us take two capacitor of capacitance C1 and C2 having different charge and potential as different charge and potential. V1 and V2 be the potential and Q1 and Q2 be their charge. We consider V1 greater than V2. We consider V1 is greater than V2 when they are new line, when they are connected by conducting wire, then charge flow from high potential, very important things, high potential to low potential till or until they have same potential level. This same potential is this same value of potential is called common potential. This is called common potential. Mean when they are connected by the wire, then charge flow from high potential to low potential until they have the same potential level. If they have same potential, they have common potential, or they have same potential level. After that charge not flow between them. In this process, very important, in this process, charge loss by 1 must be equal to charge gain by other. This is very important phenomenon. It obey हम कह सकते हैं it obey law of conservation of charge, law of conservation of charge. Charge before joining is equal to charge after joining. Charge after connecting to wire, or before connect. Here I will write charge before connected with wire, connected by wire, or connected by wire. This is law of conservation of charge. Mean charge lost not take place, only redistribution of charge take place here. We apply this conservation law before connecting. Charge on first capacitor is equal to first capacitor Q1 is equal to C1 V1. Charge on second capacitor Q2 is equal to C2 V2. Total charge. Here also we write total charge. Here we introduce this word total. Or here also we introduce the total. Net charge Q is equal to Q1 plus Q2, and Q is equal to C1 V1 plus C2 V2. We give the name this equation first, this equation second. Now we find out the total charge after connecting. We write after connecting. There is redistribution of charge take place. Charge of first capacitor. After that is Q1 dash. We can say that Q1 dash is equal to, this charge is Q1 dash, capacitance is C1 and potential is V. Charge of second capacitor Q2 dash is equal to C2 into V. Total charge Q dash is equal to Q. We add this C1 V plus C2 V. We take this. Put into, this is third equation. Put into first. From equation first. Total charge before connecting by wire is this. Q is equal to Q dash. Law of conservation is Q is equal to Q dash. Put the value of Q is from here. This is C1 V1 plus C2 V2 is equal to C1 plus C2 into V, and V is equal to C1 V1 plus C2 V2 upon C1 plus C2. This is the formula for common potential. Here V is common potential. This is common potential. This is common potential. This is common potential. We write this derivation is very important, and in exam generally asked to derive the relation for the common potential. Then we can derive this. This formula is for common potential, and we can write this formula as common potential V is equal to upper is C1 V1 is charge. Here this is the charge. C2 V2 is charge this. So this is total charge. We write as total charge upon up lower part C1 plus C2 total capacitance. Total capacitance. This is also the formula of common potential. We write in this way. Here sometime question asked as this have the potential V1 and this is V. This have potential V2 and this have V. What will be the difference in their potential? Between these potential differences, initial potential is V1 and final potential is V. V1 is higher than V. For example, this one have the potential 100 volt and second have the potential, this is V1 and V2 is, let us suppose this is 50 volt. When they combine, then common potential is 75 volt. Higher potential decreases, but lower potential increases. You understand? This have the high potential, this have the low potential, and common potential is 75. Then it means that initial potential is high for that capacitor, decreases, and initial low potential capacitance increase their potential. This decrease by minus 25 and this increase by plus 25. So high potential decrease and low potential rise. It means that this is first capacitance have change in potential and potential difference is high potential minus lower potential. And here delta V2, this is the change in potential for second. This is high value and this is low value, V minus V2. We write as this. In exam, this is very important question asked here. During the redistribution of charge and after attaining the common potential concept by these two capacitor, when they are connected by connecting wire, what will be the ratio of their change in potential? Question is here, question, find ratio of change in potential, potential mean delta V1 upon delta V2. Find out this. This is the question generally asked into exam. How we can find out this value? Let V be common, let V1 and V2 be initial potential, V1 greater than V2. After connecting by wire, और यहां ध्यान रखना है ये वायर है ना, चार्ज स्टोरेज पावर 0 है इसकी. अगर इसकी चार्ज स्टोरेज पावर 0 होगी नहीं हो तो लॉ ऑफ कंजर्वेशन ऑफ चार्ज ओबे नहीं होगा, इसलिए ये स्टोर नहीं करता, केवल इन दो के पास ही है. आफ्टर कनेक्टिंग वायर दे हैव common potential V. Then first change in potential in first change in potential of first capacitor, that is delta V1, or delta V1 is V1 minus V. V1 minus V. Put value of V1 and V, we write here, then second we write here, delta V1 is equal to V1 minus V. Put value of these V1 and V. We know very well V1 is V1 and V is this. This is the formula of common potential. Put here. C1 V1 plus C2 V2 upon C1 plus C2. Taking LCM and solve this part. LCM is C1 plus C2. This is the LCM. We multiply with this, it gets C1 V1 plus C2 V2. This is minus sign and internal sign are also changed, and C1 V1 minus C2 V2. Here you see C1 V1 cancel to C1 V1. One is positive and other is negative. And finally, this is C2 V2 and this is C2 V2. V2 taken as common, and this is, sorry, this is C1 and C2. When we take this common, C1 multiply by this is C1 V1 and multiply C2 this is C2 V1 here, V1 here, because we multiply to this only V1. So here C2 V1, here C2 V2. Common is, we take common from this and this is C2, we take the common C2, and interior part here is V1 and here is minus V2 divided by C1 plus C2. This is delta of V1. Very important. This is delta V1. Similar, we find out the value of this. Here also find second part, change in potential of second capacitor. Delta of V2 is equal to, here V minus V2. Why we take V minus V2? Here we take V1 minus V2. This concept is clear from here. I have already cleared here. Delta V1 is equal to V1 minus V, because this is high potential, it reduces. This is low potential, it rises. So V is greater than V2, but we write here as like this, V1 greater than V greater than V2. This is the concept. So put value of V and V1. Here V is from this formula C1 V1 plus C2 V2 divided by C1 plus C2, minus of V2 taking LCM, and we get the LCM C1 plus C2, and by taking this LCM as C1 plus C2, here is C1 V1 plus C2 V2 minus, multiply C1 with C2, this is C1 V2, and multiply C2 with this is C2 V2. Which term cancel here? Second term cancel here. C1 taken as common. Here we take the common C1 and we get delta V2 is equal to, we take common C1 and remaining part is V1 minus V2 divided by C1 plus C2. This is the second part. And what we want to calculate? Delta V1 upon delta V2. And put this value in this equation, and finally we get the answer as, here I will put. So I will get here this equation, we give the name of this equation is any name we are giving here. This is third equation, we can say that. This is fourth equation, we can say that. Divide equation third by equation fourth. Then delta V1 by delta of V2 is equal to, value of delta 1 is this, C2, we write here C2 V1 minus V2 upon C1 plus C2 divided by, value of delta 2 from equation 4 is C1 V1 minus V2 upon C1 plus C2. Is it clear? From here, upper and lower part, this V1 V2 cancel to this V1 V2, this C1 C2 cancel to this. Remaining term is only and only delta V1 upon delta V2 is equal to C2 by C of 1. Very important conclusion here. Ratio of change in potential equal to the reciprocal. Here, this is V1, change in potential of first, and this is the capacitance of first. This is the reciprocal effect. Finally, we write, this is very important article. This is very important article. So in exam, this is also asked, find the value of this and this, then you can prove in this way. We write change in potential first and change in potential second की रेशियो उनके कैपेसिटेंस के रेसिप्रोकल की रेशियो के इक्वल होगी. It is the equivalent to the ratio of reciprocal of these. This is the basic concept of potential, common potential energy, and how change in potential be calculated. Now we see in this process, when two different capacitors connected by a conducting wire, in this process there is some loss of energy take place. It means that energy loss mean initial when they are separated to one another, then their total energy must be greater than the total energy after they connect. It means that this energy is high and this energy is low. So after connecting, energy decreases. If energy decrease, then energy loss take place. If energy increase, gain in energy. But in this phenomena, energy loss take place, and we derive the relation how much or how amount of energy lost here. Energy loss means difference in the energy before joining. First, we find out the energy, total energy. We can say that total energy delta U. This is energy loss. Here we write as total energy, total final energy after joining, after connecting to wire, minus total energy before joining. Final energy minus initial energy is negative, then energy loss. Final energy minus initial energy is positive, then energy gain. Here we use this. Before joining, energy of first capacitor, potential energy, total potential energy is equal to potential energy of C1 plus, or we can say that potential energy of first capacitor plus potential energy of second capacitor. We write this is UI initial. Here we give the symbol UI. Potential energy is half C for first capacitor. Capacitance is C1 and potential is V1 square, plus for second half of C2 V2 square. This is first equation. Here capacitance is C2 and potential is V2. Here capacitance is C1 and potential is V1. This is before joining. After joining, total energy, U final energy is equal to, we write this total final energy, half of C1, this have the capacitance C1, but potential is V, C1 V square plus half of C2, and potential is also V, and we can say that half bracket C1 plus C2, we take the common V of square. This is final energy after combination. Change in energy, delta U is equal to U final minus U initial. Very important formula is this. Very important formula. Put value, delta U is equal to U final is this. This is from second equation is half of C1 plus C2. This is of V square minus first equation is half of C1 V1 square plus half of C2 V2 of square. Put value of common potential. We know very well that formula of common potential is common potential. Common potential V is equal to C1 V1 plus C2 V2 divided by C1 plus C2. We already know. Put this formula here and we get as, I will write this on upper side, and then we solve this equation. Put value of V and then solve this equation as like, put this value of potential here, and I will write here delta U is equal to, this value is half C1 plus C2, and value of V from here, this value is C1 V1 plus C2 V2 upon C1 plus C2 of whole of square, minus remaining part is half of C1 V1 square minus half of C2 V2 of square. We solve. This is half of C1 plus C2, this square of this equation, and we write as C1 V1 plus C2 V2 whole of square, and this is also square of lower part C1 plus C2 whole of square, and remaining part is C1 V1 square minus half of C2 V2 of square. This cancel to this one power, this C1 plus C2 cancel to this, and remaining terms is, we write here, this became half of, this formula is C1 plus C1 V1 C2 V2 square is half of C1 square V1 square A square plus B square plus 2AB, C2 square V2 of square plus 2 C1 C2 V1 V2, we write as divided by C1 plus C2, we write as like this, minus remaining part is half of C1 V1 square minus half of C2 V2 of square. Taking LCM, LCM is 2, 2 and 2 is same. Here C1 plus C2, here is nothing. So LCM is 2 C1 plus C2. This is the LCM. So 2 C1 plus C2 is same, then upper part as like this, C1 square, C2 square, V2 square, 2 C1, C2, V1, V2 minus. These two cancel to this two, C1 plus C2 multiply to this. First we multiply with C1, this is half of C1 square, V1 square. Then multiply to C2 this, half of C1, C2, V1 square minus this also multiply to this, 2 cancel to 2, then C1 multiply to this, this is half of C1, C2, V2 square minus, then multiply to C2, half of C2 square V2 of square. The term which are same but in opposite sign we cancel. Cancel it. 2 is sorry. This 2 not come here. Only 2 cancel to 2. This 2 cancel to 2. This is the remaining part here. This C1 V1 square cancel to C1 V1 square. One is positive and other is negative. This C2 V2 square cancel to this C2 V2 square. Because in both the side this is same. Then we get the answer as remaining parts now is 2 C1 C2 V1 V2 minus C1 C2 V1 square minus C1 C2 V2 whole of square divided by 2 C1 plus C2. We take common. Common is C1 and C2 with the common. This C1 C2, this C1 C2 and this C1 C2 we take common. C1 C2 we take common and remaining part is 2 V1 V2 minus V1 square minus V2 of a square upon 2 C1 plus C2. We take common minus, we take common minus C1 C2 and remaining term is these are formed as positive V1 square plus V2 square minus 2 V1 V2 upon 2 C1 plus C2. We write as this is the formula of A minus B and we write here as this formula is right here and it became delta U is equal to minus 2 minus C1 C2 upon 2 C1 plus C2 into this is minus C1 C2, this is 2 C1 C2, right as this is A minus B whole of square. So it became V1 minus V2 whole of a square. From this equation, we get V from above. From above, V1 minus V2 square always positive. Always positive. Because square of anything, square of positive is positive, square of negative is positive. C1 and C2 always positive. Always positive. So this term is positive, this positive, this positive. So we can say that delta U is equal to negative. For delta U negative mean it is less than 0. Less than 0. But delta U is U initial minus U final minus U initial. Less than 0. It means that U final less than U initial. U final less than U initial. Finally, we say that energy loss take place in this process. It is called energy loss. Energy loss take place in this process, and this is the formula of energy loss. This is the formula of energy loss. In this way, we can understand the concept of common potential. In next video, we discuss the question related to this chapter. अगले वीडियो में मैं इससे रिलेटेड क्वेश्चन कराऊंगा. आप इस टॉपिक को अच्छे से समझें. धन्यवाद.